Hello, Zeba, can you hear me? Yeah,
Yes,
okay.
ma'am.
I think Jaslyn is not joining, so let us start. Okay. So we have completed question number 5. Is there any confusion here?
No, ma'am.
Okay. Let us do question number 6 now.
And ma'am, our exam is going to start on 11th
Sorry, Zeba, what are
December.
you saying?
Ma'am, our exam is going to start on 11th December and first is March only.
Sorry, your voice is breaking. I'm not able to hear. Your exam are in December, right?
Yes, ma'am, December 11th and first exam is only maths.
Only maths. And what is the syllabus?
Till now, actually, ma'am didn't give us the syllabus, but very soon she told she'll give the syllabus also.
Hmm. So you can send it to me on my WhatsApp, right? Please write the date of the exam and everything so that I can know about it so I can plan it accordingly.
Okay, ma'am.
Okay. Yeah, so sixth question. The diagonals AC of a parallelogram ABCD bisect angle A. Bisect means angle, if I just name it angle 1 and 2. So that means angle 1 and 2 are equal, right? Okay, show that. It bisects angle C also. So that means if I name these two angles, let's say 3 and 4, so you have to show that 3 and 4 are also equal, correct? So let us write down what is given in this question. ABCD is a parallelogram. Important thing. Okay, ABCD is a parallelogram. So this is given. See, you can write complete. In short, I just write like this. Please don't write like me. And also given that angle 1 is equal to angle 2. Now you have to prove. So first part, you have to prove that angle 3 is equal to angle 4. Correct? Okay. Second part, it's a rhombus. So that later on we will see. Let's do this one. Now proof, part 1. Okay. So we can bring some relation between 1, 2, 3, 4 like that. Now see, ABCD is a parallelogram. It is given. Is that right? Yes.
Yes, ma'am.
ABCD is a parallelogram. So this thing is given. Now, if it's a parallelogram, so that means this side DC is parallel to AB. Is that okay? So you see like this, if DC is parallel to AB, right? And then you have a transversal like this. So this angle will be equal to this angle. What kind of angle they are? Come on, what kind of angles they are? Alternate interior angles, isn't it? Alternate interior angles, right? Alternate means one is on the left side, one on the right side. That is why they are called alternate. Interior means they are inside the parallel lines, right? Both are inside the parallel lines. Okay. So 3 is equal to 2. Okay. Now again, if I say, um, now if I say like this, that the side AD is now parallel to BC, correct? In this parallelogram. So now I'm looking at it like this. This is your AD and this is your BC. Now this is a transversal AC, right? So that means this angle is equal to this angle, isn't it? This time. Yes. So this is my angle 1 in the figure and this is 4. So therefore I can say angle 1 is equal to angle 4. Again, alternate interior angles, right? And one thing is given in the question, that angle 1 is equal to angle 2. This is given. Now if you combine all these three, like you can name them, this is equation number 1, this is 2, and this is 3. Now look at 1, 2, 3. How can you combine? So you start from here, equation number 1. So angle 3 is equal to angle 2, right? Now from equation 3, you can see angle 2 is equal to angle 1. So that means you can write here angle 1, right? Now from second, you can see angle 1 is equal to 4. So you can write 4. Is that correct? And you have to prove only this, that 3 is equal to 4. So from here, you can say, so angle 3 is equal to angle 4. Is that okay? Or and also you can say, so diagonal AC bisects angle C. So we have proved it. Is that okay, Jaslyn, Zeba? My voice is low. Is it fine now? Yes, now is it fine? Jaslyn, Zeba?
Yes,
Yes, Zeba, can you hear me? Jaslyn?
yes, ma'am.
Okay, okay. So far, have you understand?
Yes, ma'am.
Okay. Now let us do the second part of this question. So in second part, you have to prove that ABCD is a rhombus, right? So this is my figure if I draw it again. So A, B, C, and D. And this is the diagonal which is given. And the angles I have named like this. Same way you have to name 1, 2, 3, 4. So this is actually the same figure because it's not visible on my screen. So I'm drawing it again, right? You can use the earlier figure also. Now you have to show that it is a rhombus. First of all, what are the properties of a rhombus? What is a rhombus? Who will tell me? Yes, what is a rhombus? So for rhombus, first of all, it is a parallelogram, correct? It is one of the kind of parallelogram. There are three kinds of parallelogram: rhombus, square, and rectangle, right? Okay. Now, how is it different from rectangle and square? Okay, the second day, all sides are equal, right? Okay, in a rhombus, first of all, you have to show that it is a parallelogram. Second, now parallelogram can be a rectangle also, it can be a square also. So you have to show that all sides are equal. That's it. Because the corner angle you don't have to show here. If you have to show it is a square, then one additional thing that this angle is 90, that also you show. Remember the last question? Okay. See, in bracket for your remembrance, you can write. Now, what is the property of a rhombus, right? So that you don't forget. First thing, that it is a parallelogram. Second, all sides are equal. So that means these two things you need to prove here. Is that okay? Now, the first thing is already given in the question that it is a parallelogram. So we don't have to do it. We just have to show that all sides are equal, right? Okay. Uh, Now how we will show it? So since it is already a parallelogram, right? So since ABCD is a parallelogram, already it is given. So in a parallelogram, the opposite sides are equal, correct? So I get AB is equal to CD and AD is equal to BC. At least this much I get from here. I can say equation number 1, equation number 2. You can write opposite sides of a parallelogram are equal. Is that okay? So I can just say that opposite sides are equal. AB is equal to CD. I'm not saying that AB is equal to BC. Okay. Only opposite. AB is equal to CD and AD is equal to BC. Okay. Now I have to show that all the four sides are equal. So one more relation, I mean between this and this. So I have to relate these two sides somehow. Okay. How will I do it? So I take this triangle, this one. So in triangle ABC. Now already I have shown that all the four angles are equal, 1, 2, 3, 4, right? So angle 2 is equal to angle 4, already proved. So if in a triangle, if in any triangle, two angles are equal, that means opposite sides are also equal. So therefore, AB is equal to BC, right? Isosceles triangle. Sides opposite to equal angles are equal. This is the property we have learned. Okay. So you can mark it equation number 3. Now you look at your equation 1, 2, and 3. How you will relate it? You start writing equation number 1. So from 1, 2, and 3. See, first is AB is equal to CD, right? Now where is CD? Uh, okay, CD is not there. So AB, look for AB. Look at 3. So AB is equal to BC. So that means you can write BC here. Is that okay? Because AB is equal to BC. Now look at second. So BC is equal to AD. So BC is actually equal to AD. So this is how you can combine it, right? From any equation you can start. Understand? For example, let me write third one first of all. So I'm writing AB is equal to BC. Is that okay? I'm writing the third one. Now from second, you can see BC is equal to AD. So I write here AD. And then from 1, no, AD. Okay, so AD is not there in any other equation. So from 1, you can see AB is equal to CD. So AB is equal to CD. So now all the four sides of this parallelogram are equal. Okay. Or in sequence, if you want, you can write AB is equal to BC is equal to CD is equal to AD. So all four sides of this parallelogram ABCD are equal, right? Therefore, ABCD is a rhombus. See, I'm writing parallelogram, not quadrilateral, because this was already given. This is the first condition. It has to be a parallelogram. Secondly, all the four sides should be equal. Zainab, can you hear me?
ma'am.
Yeah, you are coming after a gap. How was your exam?
Good, ma'am. Alhamdulillah.
Okay. So I have started the chapter quadrilaterals. I hope you are catching up.
Yes, ma'am.
Yeah, Zainab.
Yes, ma'am.
Okay, your voice is actually breaking a little bit. Can you just type? Like, have you studied the introduction of this chapter already, or should I revise it one more time?
No, ma'am. I haven't started.
You have not started. So let's have a quick
No.
revision because only 6 questions I have done so far. So you will be able to catch up. So it's for everyone. Let's have a quick revision of quadrilaterals. Okay. Right. So, okay. Now, quadrilateral can be of three types. Okay. Understand it like this. It can be of three types. First of all, make this flow chart so it will help you to remember. Now, the first kind of trapezium, is trapezium. First kind of quadrilateral, right? Okay. Then second is parallelogram, and the third kind is a kite. Okay. Now, what is a trapezium? What is the difference between all these three? Try to understand. In a trapezium, any two sides are parallel. So this side is parallel to this side. I'm not saying equal, okay? Just parallel. So if these two sides are parallel and then you join it, so it becomes a trapezium. So A, B, and C, D. So basically, AB will be parallel to CD. That's it. Only one condition for the trapezium. Now, parallelogram. In parallelogram, opposite sides will be parallel, right? So this side will be parallel to this side, and this side will be parallel to this side. Understand? So AB has to be parallel to CD and AC will be parallel to BD. So it will be a parallelogram. Correct? Okay. Now kite. In kite, what happens is it looks like this, the shape of a kite, right? So if I call it A, B, C, D. Now here opposite sides are not parallel. The adjacent sides are equal, right? That means this side will be equal to this side and this side is equal to this side. Adjacent means one after the other. So you write that AB is equal to BC and AD is equal to CD. That's it. Or in words if you want. So adjacent sides are equal. Understand?
Yes, ma'am.
Okay. Now you look at parallelogram. So I'm saying AB is parallel to CD, AC is parallel to BD, right? Now, if I draw three figures, like I'm drawing a figure like this, then I'm drawing a figure like this, and then I'm drawing a figure like this. So this is a rectangle, this is a square, this is a rhombus. And I name it like this: A, B, and C, D. Same way, A, B, C, D. A, B, C, and D, right? So in all the three figure, this condition is satisfied. In rectangle, AB is parallel to CD and AC, no, something wrong I have named. AC is parallel to BD. A, B, C, D. Okay, so this way I have to name the same way as I have drawn it. Just 1 minute. Otherwise, you'll get confused. So name ABCD the same way I have named again before. Okay, same way. A, B, and C and D. Okay, so there was a mistake here. C, D. Anyway, just a name, doesn't matter. A, B, C. Right? So, as you can see in all the three figures, in rectangle also, AB is parallel to CD. In square also, AB is parallel to CD. And in rhombus also, AB is parallel to CD. So basically, a parallelogram is of three types. It can be a rectangle, it can be a square, it can be a rhombus. All three figures are basically parallelograms. Now, what is the difference then? If all the three are parallelogram, then there must be some difference. That is why they are different figures, right? So between, you can look at the figure and tell very easily. So in rectangle, apart from the parallel condition, opposite sides have to be equal, right? AB is equal to CD and AC is equal to BD in this figure, right? This is equal to this and this is equal to this. Okay. Now there is an issue. If a figure is like this, for example, right? A, B, C, D. Now I'm saying that AB is equal to CD and this is equal to this. So do you think it's a rectangle? No, it's not a rectangle, right? Why? Because this angle is not 90 degree. So this one of the angle, corner angle has to be 90 degree. So angle C is equal to 90 degree. So this is the additional condition. So these three conditions are to be satisfied for a rectangle. Is that okay? Okay, now square. In square, all the four sides have to be equal. So AB is equal to BD is equal to CD is equal to AC in this figure. Plus this angle has to be 90 degree. Angle C is 90 degree. Okay. Now in a rhombus, is equal to BD is equal to CD is equal to AC and the corner angle is not 90. So this is the additional thing in square, that the corner angle is also 90 degree. I hope it's clear now, Zainab.
Yes, ma'am.
Okay. Let us quickly look at the theorems. So I'm not proving it right now. You can like take the video of the previous class. I'm just discussing, right? Just ask for the video from the office, they'll give you. So the first theorem is a quadrilateral is a parallelogram if its opposite sides are equal, right? Let me just summarize the theorems quickly for you to remember. A quadrilateral, any quadrilateral is a parallelogram if, so first thing, it will be a parallelogram if opposite sides are equal, right? And plus converse. That means if in any quadrilateral opposite sides are equal, no, sorry. What will be the converse? Uh, any quadrilateral is a parallelogram if opposite sides are equal, right? Now, if in any quadrilateral opposite sides are equal, then it's a parallelogram. And if it is a parallelogram, then opposite sides are equal. Understand? Both way it is true. Is that okay? See, if I'm saying that it is a parallelogram, this means opposite sides are equal. Correct? Now, if I'm saying opposite sides are equal, this means it is a parallelogram. Is that clear?
Yes, ma'am.
Okay, so both way it is true. Now second, opposite sides are equal, and obviously opposite angles are equal. Okay, opposite angles only. Third, and plus converse. So if opposite angles are equal, then it's a parallelogram. If it's a parallelogram, then opposite angles are equal, right? Okay, third, the diagonals bisect each other. Important. The diagonals bisect each other. So if any parallelogram, this is a theorem which you have to remember, that one diagonal divide the other diagonal into two equal parts. And the fourth is um, it's one pair of opposite side are parallel and equal, right? There are two words, parallel also and equal also. Now try to understand, right? Now try to understand. And only one pair, please note. You can make a circle so that you remember. Now see theorem number one, opposite sides are equal. Second, opposite angles are equal. Okay, look at the first one only. Opposite sides are equal. So I'm saying that both the pair of opposite sides are equal. And fourth, it is saying that only one pair. Now, in a parallelogram, let's say I have A, B, C, D. So if only one pair, for example, AB is parallel to CD, right? Plus AB is equal to CD. That means if I talk of only these two lines, if they are parallel and equal, then also ABCD is a parallelogram. Understand? Yeah, I think it's clear now. There is one more theorem. So Zainab, you can take previous notes. So in the sequence, I have done all the theorems. You can just note that the diagonals of a parallelogram divides it into two congruent triangles. And you have to do its proof also. It can come in exam. So that means if you have a quadrilateral, parallelogram, A, B, C, D, and then this is the diagonal. So the AC will divide it into two congruent triangles. So that means triangle ABC will be congruent to triangle ADC. Is that clear? So far only this much properties I'm using. So let's move to question number 8 of the exercise. Yeah, there are two more things. One is called the angle sum property. You should know when you are studying quadrilateral, there's nothing in this. You can have any shape, any uh, shape of a quadrilateral. Sorry, it's not a quadrilateral. You can draw any shape like this. It's a quadrilateral. A, B, C, D. So angle sum property means sum of all the angle. That means angle A plus angle B plus angle C plus angle D. This is 360 degree. Remember, in a triangle it is 180, in a quadrilateral it is 360. That's it. Okay. And yeah, was there any other thing we studied about quadrilaterals? Zeba, is there anything I'm missing here? Let's do question number 8 now. Now see, ABCD is a rectangle in which the diagonal AC bisects angle A as well as angle C. So I'm drawing it here. A, B, C, and D, and the diagonal AC. So ABCD is a rectangle in which diagonal AC bisects angle A. Bisects angle A means this angle is equal to this angle, right? Angle 1 is equal to angle 2. Write down whatever is given. So ABCD is a rectangle. So already given that ABCD is a rectangle. Okay. Angle 1 is equal to angle 2. As well as angle C. That means angle C is also bisected into two equal parts. So angle 3 is equal to angle 4. Show that ABCD is a square. So you have to show that ABCD is a square. So what is the difference between rectangle and a square? In rectangle, only opposite sides are equal. In a square, all the four sides are equal to each other. So let us prove it. So you can write that any rectangle, or you can say a square, is a rectangle basically with all sides equal, right? So already it's a rectangle. You just have to show that all sides are equal. Mm, So if I look at like this, now AD is parallel to BC. See, why is it parallel? See here, AD and BC. Why I'm saying it's a parallel? Because ABCD is already a rectangle and a rectangle is a parallelogram, right? And this is the property of a parallelogram, that the opposite sides are parallel. Is that clear? Okay. So AD is parallel to BC. Now you look at like this. This is AD and this is BC, and then there's a transversal which is cutting. So what will happen? So this acute angle will be equal to this acute angle. This is angle 1 and this is angle 4. Correct? And AC is transversal. So if I look at it like this, so I get angle 1 is equal to angle 4, alternate interior angles. Correct? Okay. But angle 1 is equal to angle 2. It is given in the question. So therefore, what I get, angle 2 is equal to angle 4, right? From these two, I get angle 2 is equal to angle 4 if I combine these two, right? Okay. Now 2 and 4 are falling in this triangle. So now if I look at this in triangle ABC, now what is happening? Angle 2 is equal to angle 4. So I can say that AB is equal to BC. So in an isosceles triangle, what happens? Opposite angles are equal. And if opposite angles are equal, then the sides are also equal. So sides opposite to equal angles are equal, right? So I have got AB is equal to BC. You can mark it as equation number 1. Okay. Mm, now, now it's already given that ABCD is a rectangle, right? So since ABCD is a rectangle, that means opposite sides are equal. So we can say AB is equal to CD, and we can say AD is equal to BC, isn't it? Right? So this can be your equation number 2. Now if you combine equation 1 and 2, what will happen? From equation 1 and 2. Now you combine them. So how will you write? Write equation 1 first of all. AB is equal to BC. Now you look for BC in second. So BC is equal to AD. So you can write AD here. And AB is equal to CD. So you can write CD here. So now in this figure, AB is equal to BC is equal to CD is equal to AD, right? Hence, you can say that ABCD is a square. Is that clear?
Yes, ma'am.
Okay, next question now. Question number 9. Yes, this is question number 9. Let us solve it now. In a parallelogram ABCD, so note down whatever is given. So ABCD is a parallelogram. So when I'm saying it's a parallelogram, that means all the theorems of parallelogram are now applicable on ABCD. Understand? All the theorems. That means opposite sides are equal, opposite angles are equal, opposite sides are parallel, and diagonals bisect each other and everything. Yeah, so there is one more theorem, Zainab. Now I'm remembering, in a quadrilateral, there's additional thing. For example, ABCD is any quadrilateral, right? So the adjacent angles, that means if I take angle B and angle C, so angle B plus angle C is 180 degrees. So adjacent angles are supplementary, right? Or if I take angle A plus angle B, then it will be 180. Or angle A plus D will be 180, or C plus D will be 180. Understand? So I'm not writing that down, just telling you. ABCD is a parallelogram, right? 2 points P and Q are taken on diagonal BD, right? As you can see, P and Q are taken on the diagonal BD of ABCD such that DP is equal to BQ. So that means this much part DP is equal to this BQ. Understand? So DP is equal to BQ given. Show that. Triangle APD. Now where is APD? This is APD. Clear? Is congruent to triangle CQB. Okay, let's do one by one. So to prove, you can write. I'm just doing the proof of one part. So can you look? So there are two things you have to see when you try to show congruency. You look at all the sides, then you look at all the angles. Is there any relationship between the sides here? Who will tell me? Only one side is given that we can use. DP is equal to BQ, correct? Right? Okay. And also because ABCD is a parallelogram, so the opposite sides will be equal. So I can say BC is equal to AD. This also I can say, isn't it? Yes. I mean, this side BC will be equal to AD because ABCD is a parallelogram. Okay. Now the third side, QC and AP. No relation is given. So you have to look at some angle. Is that clear? Now again,
Yes.
yeah. Again, ABCD is a parallelogram. So see like this. If you have this A, D, and then B and C, right? And this is the diagonal. So it's a parallelogram. So that means these two sides are parallel to each other and it's a transversal, right? That means this angle will be equal to this angle. What kind of angles they are? Alternate interior angles, right? So in the figure, if I name it, so this angle, let me call it 1, and this angle, let me call it 2. Understand? Let us write it. You can say since ABCD is a parallelogram, right? So that means AD is parallel to BC and BD is transversal. BD is transversal. So you can say therefore angle 1 is equal to angle 2. Alternate interior angles, right? Okay. Now you take these two triangles. So in triangle APD and triangle BQC. Now I have angle 1 is equal to angle 2, which I have proved. Then one side is given, which is equal. So I can say DP. So sorry, it was DP, right? Which was equal. So DP is equal to BQ. And also I can say AD is equal to BC. Why? Opposite sides of a parallelogram are equal. So which criteria? Two sides, one angle. So SAS criteria, triangle APD is congruent to triangle BQC. Done?
Done, ma'am.
Now, second part. So you have to show AP is equal to CQ. Now, AP is part of this triangle only, right? This is the side AP and this is CQ. So from CPCT, you can say they are equal. So since triangle APD is congruent to triangle BQC, so from CPCT, we can say that AP is equal to CQ. Okay, this is B here. Now, third part. You have to show that triangle AQB is congruent to triangle CPD. Now, where is AQB? AQB means this, this triangle, right? AQB. And CPD means this triangle. Is it visible? These two you have to take. Mm. So one side I can see AB is equal to CD because opposite sides of a parallelogram ABCD, right? So at least one side I can say equal. And yeah, again, this BQ is equal to DP already given in the question, and which is again part of this triangle. So second side also I have got, and one angle I can again take. So if this side is parallel to this side and this is a transversal, so what will happen this time? Or you see like this because you need this angle, right? So you take like this side is parallel to this side and this is a transversal. So that means this angle will be equal to this angle. Is that clear? So if I just name it angle 3 and I name it this one angle 4. So ABCD is a parallelogram. Therefore, AB is parallel to CD, right? And BD is transversal if I take. So therefore, angle 3 is equal to angle 4. Alternate interior angles. Understand? Now you look at the two triangles. So in triangle AQB and triangle CPD, there are three things. First, you have one angle. Angle 3 is equal to angle 4, which you have proved. Then you can say AB is equal to CD, right? Opposite sides of a parallelogram are equal. Is that clear? AB is equal to CD. That means this side will be equal to this side, right? Okay, and PQ is equal to DP, which is given in the question. So you have SSA criteria. SSA criteria or SAS, what you call it? No, angle is in the between, so we call it SAS, right? We are taking two sides and the middle angle we are taking. So SAS. Triangle AQB is congruent to triangle CPD. Yeah, so in the fourth part, you have to show AQ is equal to AQ means this side is equal to CP. So this is part of this triangle. So from CPCT, we can show it, right? So for fourth part, you can say triangle AQB is already congruent to triangle CPD, and by CPCT, you can say AQ is equal to CP. Right? Now you look at the fifth part of this problem. See, this is the diagram. Okay, this is the figure. Now this time you have to show, I mean fifth part, you have to show that the inner rectangle, as you can see, the inner quadrilateral APC, sorry, CQ is a parallelogram. Understand? APCQ. That means this one, APCQ. You have to show it's a parallelogram. So what is the property of a parallelogram? Opposite sides are equal. So in previous part number second and fourth, what we have proved? From part second, right? We have proved that AP is equal to CQ, right? Now, from part fourth, just now, we have proved that AQ is equal to CP. Getting it?